All right, fifth grade, we learned about magnets in first grade, so we're just gonna do a quick review of what we already know, and then we're gonna learn some new tricks. As you know, a magnet has a north and a south pole. They're only on one side, so if you don't see them, you flip it over there. And what happens when I try and put a north pole with the north pole? Repels. But what happens when I switch and make them opposites? They attract. Opposites attract, like poles repel. There's no on switch. These magnets are turned on all the time. You cannot turn them off. That's what they're called, permanent magnets. And they are from the earth. We find these in the ground. Here we have a compass. And what does a compass have to do with magnets? Well, a compass works because the earth is a giant magnet. And to prove that the compass measures magnets in the earth, I can hold a magnet near it and then rotate it. And what happens? It switches. So the red points to the south and the white points to the north. Now I can't change this. This north is always going to be north. It's stuck like this. I don't even have to be close to the compass. All the way from over here, it starts to affect it. Look at that. When we're done with these, please do not leave the magnets on top of the compass or even next to it, because I think it will weaken the compass. So after we've tested this, make sure the magnets are on one side and the compass on the other. Now with your permanent magnet, you're going to touch these different objects and see which ones are magnetic and which ones are not. Some of these have iron in them and some of them do not. You might think that all metal is magnetic, and you will be surprised when you find out today. And now we get to work with an electromagnet. There's electricity from this battery that's going to go into what is called a solenoid. A solenoid is a piece of iron with wire wrapped around it. And this by itself, you'll see, is not magnetic. Is not attracted to the iron in the ring there. But when I turn it on, again, this is a circuit. Right now the circuit is open, so it's turned off. I'm going to turn it on by just holding it on there. And now it is a magnet. Now what happens when I disconnect the circuit here? What should happen? It turns off the magnet.
Oh, God.
And then he releases the electricity and bam, it goes.
So unlike the permanent magnet, which can pick it up, I cannot turn it off. It is always attracted to the iron. And it doesn't matter which pole I use, they're both attracted permanently. Right now is turned off. The circuit is open. The current is not running until I turn it on, and now it works. Now this is gonna get hot after a couple of seconds, so it's important that you only do this for like 3 to 5 seconds. 1, 2, 3, 4, 5. I don't feel anything, it's fine. Even after 3 seconds, if it's still cool, we still want to disconnect it so we don't waste the battery and then eventually accidentally start a fire. So a couple of seconds is fine. Turn it on, attract, turn it off. And we said earlier that the north on a permanent magnet is always north and the south is always south. You see how they switch there. But the north is always going to attract the silver there, and south is going to always attract the red there. Do you remember we talked about circuits and how the electrons are negatively charged and they're repelled out the negative and into the positive, right? So if I do it this way, I've got the silver end pointing at the tip of the nail. What happens if I take this battery and rotate it? So now the negative is up here. Look at that. Now the red is attracted to the same tip of the nail. Flip it over. Now the silver. So unlike a permanent magnet where south is always south no matter what, I can make this electromagnet switch poles without even moving the nail. All I do is move the battery, switch the direction of the electrons. So an electromagnet can be turned on and off. You can switch the direction of the magnetic poles by switching the electricity direction. And what do you think would happen if I used 2 batteries instead of 1? Yeah, it makes this even stronger. So you can make a super magnet with adding more electricity in it. Meanwhile, this permanent magnet cannot be turned on or off. You cannot change the power, and the north will always be north and this side will always be south. When it's time to clean up, we have to separate the solenoid from the power source. Why is that important? Well, if you put this in the basket and these two accidentally bump into each other, closing that circuit, that electricity, as you know, is going to run through, and eventually what's going to happen? It's going to overheat and maybe even start a fire, or at least waste the battery. We don't want to do that. So I'm going to put the battery inside an insulator. This plastic blocks electrons. And so now, even if they accidentally close the circuit while they're in the basket, you'll see that the magnet doesn't work because the plastic is blocking those electrons. And that's what we want.